welcome to Math Just Got Easier for You. Today's lesson is on laws of exponents. This is lesson number 2, and we're going to be looking at power to a power. Now, the law, whenever you have a power to a power, just such as what we have here, x to the third power raised to the power of 11, the law for this is that you have to multiply the exponents. So let's go ahead and do that here. Since we have a base of x, and we have this to the power of 3 raised to the power of 11, we're going to keep our same base, and we will multiply, as the law says, 3 times 11. And this leaves us with the final answer of x to the power of 33. Let's look at the second one. We have a base of 5, so we keep the same base, and we're going to raise power to a power. So 5 raised to the power of 2, or 5 to the second power raised to the power of 15, is the same as saying 5 raised to the power of 2 times 15. And we know that 2 times 15 gives us 30. So our final answer is 5 to the power of 30. Now let's look at some more complex problems dealing with power to a power. Now, if you remember the distributive property, when you are raising a power to a power and you have numerous exponents inside of the parentheses, we must be fair and distribute that exponent to all of the other exponents on the inside. So we're not just raising 1 to a power of 2, we're raising each one of these to the power of 2. So if I were to rewrite this, I have x as my base, and I have 4 as that exponent, and I'm going to multiply it times 2 because the rules still apply for power to a power. Since we have y to the power of 9, and that's raised to the power of 2, which means I'm going to have to multiply 9 times 2. And then I have my z, which I have to the power of 10, and I'm raising that power to a power of 2. So let's go ahead and simplify. So we have x raised to the power of 4 times 2, which gives me 8. And then I have y to the 9 times 2, which gives me 18. And I have z to the power of 10 times 2, which equals 20. All right, so let's look at the second one. Here we have 4 times x to the power of 8 times y to the power of 2, and all of this is raised to the power of 3. Now, one of the things what we see here is 4, it looks as if it does not have an exponent. However, all numbers in all letters, variables, have an exponent. And when you do not see an exponent, it's automatically a 1. So that rule applies to any number, any variable. If you do not see an exponent, it is automatically a 1. So whenever we take this to this 3, and we're going to distribute it to everything on the inside of our parentheses, raising a power to a power, we have 4 to the power of 1 times 3 times x to the power of 8 times 3 times y to the power of 2 times 3. Now, when we simplify this, we get 4 to the power of 1 times 3, which equals 3. We have x to the power of 8 times 3, which gives us 24, times y to the 2 times 3, which gives us 6. Now, 4 raised to the power of 3 is small compared to others. So what we can do is we can go ahead and expand that out. 4 to the power of 3 is the same as saying 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So we have 64 times x to the power of 24 times y to the power of 6. Let's look at another complex power to a power, but this is whenever we are dividing. Whenever you are raising a power to a power, once again, it's always multiplying the exponent times the power. So in this case, if you look, we know that the power of y is raised to the power of 1, right? So we have x to the second power times y to the first power, all divided by z to the sixth power. And as we said before, we're going to distribute our power to all of the exponents located inside, even in our denominator. If we were to rewrite this, we would get x raised to the power of 2 times 7 times y to the power of 1 times 7 divided by z to the power of 6 times 7. Now let's simplify that. So we have x to the power of 2 times 7, which is 14, times y to the power of 1 times 7, which equals 7, over z to the power of 42, which is 6 times 7. Let's look at the second problem. Here we have 2 times x to the power of 4 divided by 3 times y to the power of 5. And all of this is raised to the power of 2. As we stated before, when you do not see an exponent, it is automatically a 1. So since we do not see an exponent here, this would be 2 to the power of 1 times x to the power of 4 divided by 3 to the power of 1 times y to the power of 5. We have to now do our distributing property, where we're going to distribute the 2 times 1 to this exponent here, to the exponent here, and to the exponent here. Now let's rewrite it. So we have 2 raised to the power of 1 times 2 times x raised to the power of 4 times 2. And that is all divided by 3 raised to the power of 1 times 2 times y raised to the power of 5 times 2. So if we were to simplify this, then we would get 2 raised to the power of 1 times 2, which is 2, times x raised to the power of 4 times 2, which is 8, over 3 raised to the power of 1 times 2, which is 2, and y raised to the power of 5 times 2, which is 10. Now, what we're going to do is we're going to simplify this a little bit more to get rid of these smaller numbers. So if we have 2 raised to the power of 2, That is the same thing as saying 2 times 2. And 2 times 2 is 4. So that would be 4 times x to the power of 8. Divided by, we have 3 squared, or 3 to the second power, which is the same as 3 times 3. 3 times 3 is 9. We have that times y to the power of 10. And this is in its simplest form. And this is how we use the laws of exponents with complex power to power when multiplying or dividing. Please make sure you subscribe below and stay tuned to our lesson 3 of laws of exponent. Thank you so much.